Hello everyone. In Gujarat University, in the semester 1 in chemistry subject, there are two kind of exercises in the practical in semester number 1. Already we have discussed one exercise that is known as qualitative analysis. In this presentation, we will discuss volumetric analysis. So, volumetric analysis is basically titration kind of exercise. And before we discuss one of the experiment, its prerequisition is preparation of the standard solution, and that we will discuss in this part 1. So let me tell you friends, in the 12th standard or 11th standard, you are familiar with this kind of exercise. But basically the difference between both of them is that in the 12th standard, you were given standard solution as well as unknown solution ready-made. What is the meaning of standard solution? Solution with the known concentration is called standard solution, and the solution with the unknown concentration, whose concentration we want to determine, that is called unknown solution, or we call it X normal solution. So both these solutions were given to you ready-made. Here in the semester 1 at college level, the only difference is standard solution you have to prepare at your own, and you will be given unknown solution. So that is the new part. That's why in this first presentation we will discuss how to prepare standard solution. Now first let us read the aim. Prepare 100 ml zero point 0.1 normal standard solution of succinic acid and determine normality, gram per liter and molarity of X normal NaOH solution. It means that we have to prepare standard solution of succinic acid. How much? 100 ml, zero point 0.1 normal. Now friends, there are two kinds of solutions we can prepare. If you dissolve molecular weight of any substance in 1000 ml solution, 1000 ml, that is 1 liter solution, then that solution is called molar solution, 1 molar solution. But if you dissolve equivalent weight of any substance into 1 liter solution, then it is called 1 normal solution. Right? Now, suppose NaOH. NaOH is the substance whose molecular weight is 40 gram per mole and its equivalent weight is also 40 gram per mole, 40 gram equivalent. So in its case, molar solution and normal solutions both are same. Same is the case of the HCl. But friends, sulfuric acid, its molecular weight is 98 gram per mole. So you should dissolve 98 gram sulfuric acid in a liter solution, then it is called 1 molar. But sulfuric acid's equivalent weight is 49 gram per mole. So when you dissolve 49 gram sulfuric acid in a liter solution, it is called 1 normal solution. So some solutions, for them molar or normal is equivalent, but many of them it is a different. So here, as we want to prepare standard solution of succinic acid 100 ml 0.1 normal, so we should first know its equivalent weight. So there are many definitions of equivalent weight, and one of its definition for the organic acid is molecular weight of acid upon basicity. Molecular weight of this is the structural formula of succinic acid, right? Uh, Molecular weight is 158 gram per mole. Now you can see that it is a dibasic acid, as there are two COOH groups. Acid with only COOH group 1. For example, acetic acid, it is called monobasic. Succinic acid is a dibasic acid. So molecular weight, this one is 158. Now what is basicity of acid? So whenever we dissolve acid and it undergoes ionization, at that time the number of replaceable H plus or number of H plus ions which are set free on dissolution, that is called its basicity. So whenever we dissolve succinic acid, actually it undergoes ionization and set free 2 moles of H plus ions. So its basicity is 2 and basicity is 2. So its equivalent weight is 158 by 2, that is 59. It means that if you want to prepare 1 molar solution, you should dissolve 158 gram succinic acid, which is its molecular weight, into 1000 ml solution. But as here we want to prepare normal solution, so equivalent weight is 59. So we will dissolve 59 gram in a liter if we want to prepare one normal solution. So from this statement, we can write mathematical expression that if somebody wants to prepare 1 liter or 1000 ml one normal succinic acid, he or she should dissolve 59 grams succinic acid. This is the same mathematical example statement of this paragraph. It is a factor. But if you remember the aim, see, we don't want to prepare liter, we want to prepare 100 ml plus we don't want to prepare 1 normal, we want to prepare zero point 0.1 normal. So now easily we can calculate because we have this factor. 1000 ml 1 normal succinic acid require 59 gram succinic acid. So 100 ml zero point 0.1 normal require, it is a simple mathematics, 100 multiply zero point 0.1 multiply 59 upon 1000, that is 0.59 gram. 1 gram equal to 1000 milligrams. So if you multiply this with 1000, this is the milligram. So we have to dissolve, we have to weight 0.59 gram succinic acid, and whenever we will dissolve it into 100 ml distilled water, it will be solution with the non concentration, that is 0.1 normal. So this is the way calculation is being done. Now how we can prepare this solution? This is its theoretical part. Now let us check the practical. So in the laboratory, we have this kind of analytical balance or digital balance. It is the same kind of balance you must have seen at provision stores or some grocery shop or at a dairy shop. So here you can see that in this picture. If you remember, whenever you go to purchase any milk product, say ghee or curd or basudi, anything. So first of all, the container is placed on the weight scale. Then its own weight is actually converted as a zero. So here you can see that this beaker is placed over the scale. Beaker's weight is a 32.68 gram. So this is the tare key. If you press the key, then scale will not consider the beaker's weight, it will show you 0. So here you can see that after pressing tare key, now the weight is 0. Now you can add 0.590 gram succinic acid into this beaker. This kind of weight is also done on using watch glass instead of beaker, or sometimes on the piece of paper as shown in the second figure. In this figure you can see that this is also another kind of scale. Glass cabinet is given. From the side we can, it's a window, so we can easily use it or enter our hand. So here you can see that this is a piece of paper, glaze paper it is called, is a placed. Similarly like beaker, we after putting a paper, when the scale is showing its weight, we press the tare key and make its weight 0, and then we can add 0.590 gram succinic acid. Now we have to dissolve this. After weighing the substance, we have to dissolve it in 100 ml distilled water. So for that, this kind of measuring flask is used. It is shown in this figure. Now always in this measuring flask, mark is given. In this figure, this is also, this portion is zoom here. So here you can see that mark is there. So if you fill any solution up to this mark, it will be 100 ml. So what we are doing first, we are actually, after carefully weighing 0.590 substance, we add that substance, succinic acid, into empty flask, and then we add the water up to the mark. Now friends, very important thing is that in this picture you can see that carefully, if you observe, mark is here, and under the mark you can see that there is a surface of the distilled water. So this is a wrong technique, because with the mark you can see that the upper surface of the water is touched. On the contrary, this is the correct method. You can see that mark here, we have added slightly excess. We have added water in such a manner so that the lower meniscus, meaning of lower meniscus means lower surface of this water, it should touch with this mark. So this is the correct method. This is the wrong method. One more picture in the burette, because we are in titration also using burette. You should fill the chemicals or solutions in such a manner so that the lower meniscus of the solution should touch with the mark. Suppose here you can see that if you want to fill 20 ml, so this is the way you should actually fill the burette. So this measuring flask having the mark at exactly 100 ml, and whenever we add 0.590 grams succinic acid into it, so this solution now it is 100 ml and its concentration is now zero point 0.1 normal, as we have added exactly 0.590 gram succinic acid. So friend, this is the way you have to prepare standard solution, or in other words, solution with the known concentration. This portion is new for you. It is very easy. And one more thing I should tell you is this calculation you have to write into the examination before, without help of the book. So you should prepare this calculation. So I hope that before we discuss the whole experiment into the next session, part 2, this is a very important exercise of preparation of the standard solution. It involves lots of skills, because the marks of this experiment are very largely depend upon the how accurately you are getting the result, and accuracy of result is depend upon the how accurately you prepare the standard solution. If it is diluted, if it is concentrated, at every step skill is involved. So carefully you should weigh, not lesser than that, not more than that. Thoroughly you should dissolve. You should add properly into the measuring flask. So at every step your skill is required. But it is at the same time it is very easy. And in next part we will discuss, after preparing this standard solution, how we can determine the concentration of unknown solution.